If we're working with a function, right now when we're evaluating functions, later on when we're doing more complicated things involving functions, it is important to know what the domain of our function is. Now, when we define a function using pairs or a graph, it's easy to see the domain. It's more difficult to see the domain when we have a relation that's defined as an equation. There are two notions that we can think about here. First, we can think about the implicit domain of a function. And the implicit domain of a function is the set of all real numbers for which whatever expression we have for the function is defined. So for example, if we have f of x equals 1 over x, we see that in order to evaluate f of x, we have to divide by x. Right? F of x is defined to be 1 divided by x. Whatever number x is, 1 divided by it gives us our y value. And now we know that we can do division by any real number except for 0. And so any real number except for 0, we can plug that into our function and it'll make sense. So the implicit domain of f is just the set of all x that are not equal to 0. So all real numbers except for 0 are in the domain of this function. Now, throughout this course, we're going to be meeting various kinds of functions. And one of the major things we're going to do whenever we meet a new kind of function is to think about what is its domain. We're also going to think a little bit about what is its range, but the domain is going to be our biggest priority. Now, in addition to the implicit domain of a function can have an explicit domain. The explicit domain of a function is one that is explicitly described when we write the definition of the function. So we write f of x equals an expression, and then a comma, and then the restriction. So here we have f of x equals x squared, comma, x is greater than or equal to 0. The domain of f is the set of all x such that it meets the restriction. X is greater than or equal to 0. We can also describe that in interval notation, doing just a quick sketch. Right? The points greater than 0 are the ones to the right. So in interval notation, we would say 0, infinity. We can describe this domain either way. If we're typing it into a computer, computers like interval notation. But if we're doing something on paper, we can write the domain whichever way we like better. So if we want to take f of 4, plug that in for x. It's 4 squared is 16. But f of negative 2 is undefined because even though it makes perfect sense to plug in negative 2 here, we explicitly said that negative 2 is not in the domain of this function f. So negative 2 greater than 0 is false, and so negative 2 is not an element of the domain of f. If there's no explicit domain given, then we say that the domain of f must be the implicit domain.